In this video, we're going to start a discussion of the object-oriented programming concept called interfaces. Interfaces define and standardize the ways in which people and systems can interact with one another. So we can think of an interface such as the controls on a radio that serve between the radio's user and its internal components. What an interface often provides for us is controls or a limited set of operations, such as in the case of a radio, changing the station, adjusting the volume, changing between frequencies. And different radios may implement these controls in different ways, but the interface specifies what operations a radio must permit users to perform, and it generally allows us to use different types of radios and understand the functionality even if we've maybe not seen that particular interface before. So ultimately, we can think of interfaces as helping standardize. So when we have that relationship between two systems or multiple objects, it helps us control how we're interacting, right? A similar analogy could be used for a car. So a car may have a manual transmission. It could have a steering wheel, a gear shift, a clutch pedal, gas pedal, brake pedal, all of these things. And this same interface is found in nearly all cars, but it could be slightly different. However, someone who knows how to drive one particular type of car can usually just slide right into another car because they're familiar with how the interface should perform. So let's take this idea of interfaces and translate it into software. Software objects also communicate via interfaces. So a C# interface basically describes a set of methods and properties. And in this description, it also talks about the performance of tasks or what kind of information can be returned from that object. Aside from describing methods, properties, and tasks, one of the other basic functions of an interface is to help two objects, two or more objects, that don't already have any relationship, they don't have that parent-child, base and derived class relationship, they help them talk to one another and share common properties. So we would say share between two classes that do not have a relationship. So for example, we previously wrote our invoice class for our hardware store. Well, maybe we also have an employee class in our system. Now, invoice and employee, they don't share any kind of relationship. One's not a base class for the other. They don't have any common children. However, we may have an interface in between the two named iPayable that communicates with both invoice and employee. Since invoices may need to generate payable statements or use some of the methods that are declared inside of the iPayable interface, and an employee also needs to be paid. This relationship is mutually beneficial and then allows for further polymorphic activity between two objects where it wouldn't otherwise be possible. So in the next video, we're going to look at an example of an interface and work towards building a more real-world system that uses the idea of inheritance along with interfaces.